Hi, I'm Dave, and in this video, I will show you how I troubleshoot and repair my DeWalt 120-volt AC circular saw. And this will also apply to other similar 120-volt AC power tools. This is my 7 1/4 inch circular saw, model DW357. I purchased this saw new sometime around 1990, so that was like 27 years ago. I needed to make a cut a few days ago, and when I plugged it in, the saw turned about an inch and stopped. I thought it might be helpful for someone else if I make a video on how to troubleshoot this circular saw. So let's get started. Here's a very simple explanation of the electrical diagram for the saw. This is a 120-volt AC plug and power cable. Mounted on the handle is this double pole trigger switch. And this is a wire to the carbon brush, the armature, and another carbon brush and wire. With the switch closed, it sends AC current through the brushes into the armature, and the saw blade rotates. The first thing I check for using a voltmeter is there voltage present to the plug. 124 volts AC, so power is available. Next, using the ohm scale, I attach the meter leads across the prongs of the power cord. And when I press the trigger switch, the meter should read about 1.5 to 2 ohms. And nothing. The circuit is open. Here's a simple illustration. Connect the meter leads here to the plug, and the meter is checking for resistance of the circuit path through the power cord, switch, brushes, and the armature. So this circuit is open, but why did the blade move about an inch to begin with when it was plugged into the power cord? Next is to check along the power cord and inspect that no wires are cut. I do have a place where I added tape last year, but no wires were cut, just the insulation, so I think this is okay. And the strain relief around the cord, here it looks good also. Now is a good time to check the 2 motor brushes before further disassembly. I use a large flat blade screwdriver to remove the brush cap. Oh, and make sure the saw is unplugged at this point. If you use a small tip screwdriver, you're likely to damage the plastic cap. Remove the cap, and here is the brush. It looks good. It's about 16 millimeters long and 6 millimeters thick. Reinstall the brush and the cap. This is not a brush problem, and you can check the other one the same way. Here I use a Torx T20 screwdriver to remove the handle cover for access to the wiring. I'll use the drill just to speed things up. There are 2 different size screws, so remember which one goes where. Remove the handle. These 2 wires are connected to the trigger switch, which is connected to the brush holder of the motor. Using the ohm meter, I expect to read about 1.5 to 2 ohms. And that looks good. Looking at the illustration, here's what I did. I connected the meter leads to this side of the switch, and the meter will read through the wires, the brushes, and the armature. And I expected a reading of about 1.5 ohms resistance. Next, I measure from one prong of the power cord to the switch, and it should read 0 ohms. So that wire is good. Looking at the illustration, I connect the meter leads to this side of the switch and this one to the plug. And that will measure the resistance through the wire, which should be very close to 0. Next, I measure across the other prong to the switch, and I get no reading. Looks like an open circuit. Looking at the illustration, here's what I did. I connected the meter leads to this prong of the plug and this one to the switch, measuring the resistance through the wire. And this is an open circuit, so here's the problem. I suspect this prong on the plug is damaged and could cut the cord and recheck it, but let's just go a little further. Here I remove the trigger switch using a T20 Torx screwdriver and the strain relief for the power cable. This one is a T15 Torx. Attach the ohm meter at the power input of the switch. Press the trigger and the meter reads the circuit to the armature of the motor. So the switch is good, but the power cord is defective. Looking at the illustration, here's what I did. I connected the meter leads to the incoming side of the switch. With the switch closed, it will measure the resistance through the switch, the wires, the brushes, and the armature. Less than 2 ohms, so this part of the circuit is good. Here I remove the power cable from the switch using a Torx T20. Here I remove the strain relief from the power cord. Now I could have just added a new plug, but here I will replace it with a new cable. Now this new cable does not have any lugs that are needed to attach the screws to the switch. I have 2 here that I will crimp on to the wires. Using wire strippers to remove the insulation, give the stranded wires a little twist, slide the terminals on, I use crimpers to make the crimp, and some pliers will work with this also. Feed the wires through the strain relief. Attach the wires to the switch. Here I use the T15 bit for the strain relief screws. And when using a drill driver to tighten the screws, always use a low clutch setting so you will not strip out the hole. Before I reinstall the handle, I'm going to use the ohm meter to measure across the plug, just like in the beginning. Press the trigger and it reads good. It's important to make sure the wires will not be pinched when replacing the handle cover, so take your time and route them properly. Remember which holes use the larger screws, then tighten all of them. Plug up the saw, pull the trigger, now it's just like better than before. I know this video was long, but it was intended to help almost anyone to troubleshoot and repair their saw, and this can be applied to other 120 volt AC powered tools as well. I hope this video was helpful. Please subscribe for more videos, and a thumbs up is always appreciated. I'm Dave. Have a great day.